In our previous discussion on the mineral fraction of the soils, we were looking at the basic composition of the minerals. That is, what are the building blocks of which the soil minerals are composed? So if we want to really think about it, we've been looking at kind of the anatomy of the mineral structure, the internal structure. What are the cations, what are the anions, what are the basic building blocks, the tetrahedrons and the octahedrons, how do they fit together into platelets? Now when looking at a soil, under field conditions, we're never going to see any of these things that we've been talking about. You have to realize this is more on the element by element, compound by compound. These are non-visual types of things when looking at the soil. When we look at a soil under field conditions, we get a general feeling for the textural class, for the structure. These are physical properties that we can directly observe when looking at this soil. Now, from our previous discussion on soil physical properties, we've learned that all soils, especially soils under field conditions, are composed of some sand, some silt, and some clay-sized particles. Most recently in this unit on the mineral fraction, we've been talking about that clay separate, those clay particles. We've been looking at the anatomy of the clay particles, of what are they composed. Are they 2-to-1 types of clays, meaning tetrahedral sheets being 2 for each octahedral sheet? Or are they 1-to-1, where we have 1 tetrahedral for each octahedral sheet inside the platelets of the clay mineral structure? What we're going to actually be doing now is to look at more the external surface of these clay particles. The surface of the clay particles is where those nutrients that are going to become available during the growing season to a plant or crop are going to be held. Some will be in the soil, the liquid phase, the soil solution. Others will be held on the surface of these soil mineral particles. Now we've learned that the surface of these soil mineral particles has a residual negative charge. Now where did that charge come from? That charge came from the fact that some of the oxygen anions that formed the framework for that mineral structure, their negative charge is not totally offset or neutralized by the cations that are included within that structure to help stabilize it or hold it together. So what this means is that the surface of that clay mineral particle, and we'll use clay as an example here since it's the most active separate of the three in the soil in terms of the properties we're going to talk about next. These clay mineral particles have a number of these residual negative charges at their surface. Well, these charges are going to not be left unneutralized, so they are going to attract from the soil solution and hold at the surface of that negative charge. They will be holding positively charged elements, which of course we call cations. In order for a cation to be found on that residual charge site, it must also occur in the soil solution. They don't just magically appear from somewhere else in the soil environment. They're going to be found in the solution. They're going to be found on the surface of these clay mineral particles. Now we've been calling these residual negative charges. What I would like for you to remember them as from now on are what we're going to call cation exchange sites. Now let's take a look at that term, cation exchange site. Cation is an element that has a positive charge on it when it occurs as a charged particle or an ion. The next part of that term, exchange, that implies that things are moving in and out or trading places. And then, of course, site means location upon which this occurs. So if we said we're talking about a cation exchange site on the surface of a clay mineral particle, we're talking about one of these negatively charged surfaces where cations will be attracted to and held and can also be trading places or exchanging with those that are in solution. So we have cations in the soil solution. We have cations occurring on the surface of these clay mineral particles, as well as other locations, which we'll talk about here in a little bit. And these are called cation exchange sites. Now, if that were a positively charged site, and there are a few of these that do occur in the soil, then they would, of course, not attract and hold cations. They would attract and hold anions. So we have both cation exchange sites and anion exchange sites. The cation exchange sites will attract and hold positively charged elements or cations. The positive exchange sites will attract and hold negatively charged ions, which of course are called anions, so those are called anion exchange sites. Now, of these two types of exchange sites, the cation exchange and the anion exchange, the cation exchange by far dominates those types of sites which occur on the mineral particles in the soil. And for the purpose of the rest of our discussion about this, we're really going to limit our discussion to those cation exchange sites. But since this was discussed in your textbook, I did want you to be at least aware of the fact that we do have some positive exchange sites in the soil, and those are called positively charged sites in the soil, and those are called anion exchange sites. Now, I've been talking about the clay. The reason I've been talking about the clay minerals is because of those three separates, the sand, the silt, and the clay is the one which predominates in terms of having these cation exchange sites. And this process of cation exchange is a very interesting one because we need to think of this cation exchange process as being a balancing effect. And by balancing effect, what we're saying is that in order for the cation to be on the exchange site, it must also be a free cation, or one that is free or solubilized into the solution phase of the soil.